Okay. So let's start with logistic regression. First, we will do a scratch approach for logistic regression. So here we have um, create a manual data set of one dependent and one independent variable, but y is here a two binary column which have two classes 0 and 1. So it is a data set of hours studied in a day by a student, and y is the target output which denotes that student pass or fail. So hope you understand the data set. Please type this array in your cell. So to do the logistic regression, first we have to define some functions which we'll use in logistic regression. First, we have to define the sigmoid function. Sigmoid function argument has one argument which is z here, and which will return 1 upon 1 plus e to the power minus z. And then we have to predict the probability function. You remember that in logistic regression, we have to multiply our inputs by the weight function and then add a bias, which are the beta 0, beta 1. You have did in previous session, and then apply the sigmoid function on that W transpose X plus B, which will give the probabilities of the prediction, which will provides us the probability that a student will pass or fail. Sigmoid function has a range between 0 to 1. The all prediction will be between 0 to 1. So now to compute loss, just take we have taken 4 arguments here. X is the input, Y is the output of the data set, and W are the weights, and B is the bias. And first, create the number of samples. Alien function will take out the length of X, means length of rows number of X. So M will define the sample number of X. And first initialize the loss to 0, and then create a for loop to the range of M. M is the number of samples which are in X, 1, 2, 3, 4, 5, 6. These are the M. So for loop first will be for first entry of M, which is the first sample. Then Y hat is the predicted output, which will go through the predict function definition. Xi is the first sample, and weights and bias here. Predict function is given here, which is again used in the compute loss function. So then we have assigned the loss. In loss, this means loss equal to loss plus this log likelihood function yi and log of predicted y hat minus 1 minus yi, which is the output of the ith sample. We are on the first sample, so this is for the first sample, and again log of 1 minus y hat. Then we have to take the average of this again and again. The for loop will run, and this will take the sum of loss for all the samples, And then after that, when all samples will complete, the function compute loss will return loss divided by number of samples, which will give the average of loss. We have taken the minus sign, negative sign here. So we minimize this function using gradient descent. You all have understood this? Then we have defined the train logistic function, which will train our logistic model for the input data set x, y is the output, and learning rate will be take 0.1, and these are the epochs or iterations. First, we will initialize the weights uniformly, and also bias. First, we will initialize weights in bias here. Then again, M will compute the length of x. So for the number of iterations, let's we are on the first epoch. The gradients are initialized to 0. And for I in range of M, that means we are for the first sample, y hat will predict the probability for the first sample by the predict definition. Then gradient will be assigned. Gradient will be assigned to the DW, which is the gradient of the log likelihood function, which is a binary constant of here, which is y hat minus y for the sample, first sample, second sample I represent, and multiplied by xi. And for the bias, it is only y hat minus y. So we have computed the gradients for the first sample here. Then we will apply the gradient descent formula here. The weight parameter equal to weight minus learning rate multiplied by gradient. This is the gradient descent formula. And again for the bias, the gradient descent will apply. So we have done for this first sample. Again for the second sample, again for the third sample, this will done. And we have taken the epoch 1000. So we want to first this loop will complete. Then we arrive on this line. If epoch will divide it by 100 and remainder is 0, then epoch will print the loss. Loss is what? Loss is in compute loss. So after completing this loop, we have the W and B values. Then we will compute loss for every W and B. And then after this epoch, the final W and B after 1000 epochs will be written by this loop. So this the outer loop will return our final weight and bias.
Hello.
Hello. Yes.
Yeah. Sorry for interruption. I just had a quick question. I just lost the previous class. Can I get the recording of this class, or it's not available?
Yeah, it will be available by evening.
Oh, okay. Thank you.
Okay. So then we have now our final parameters, optimized parameters. Then this is the definition of train logistic. Yet we have not trained the model. So now we will train model by the train logistic definition. Just provide the input and output here. And WP will be written by this. So we have defined this definition of train logistic. Now you can check this definition of different data sets of this type of data set, which we have defined earlier. Then print the final weight, which is W, and the final bias. You can see here for epoch 0, the loss is 1.04. For epoch 100, the loss is 0.44, and it will decreasing by the time. So now we have to plot our result of logistic regression, and we have taken a parameter x plot, which will take 100 values between 0 to 6. Why have we have taken 0 to 6? Because our data has minimum value 0 and upper value 6. So all the points will be visible between 0 to 6. That's why we have taken 0 to 6. And y predicted variable will have the probabilities for provided x and w in x for all values of between 0 to 6. X in x plot, that means x will be in 0 to 600 times, and predict definition already have given earlier. This is the definition. So this will predict the probabilities for all points. Now plotting, this will give us the figure size, and the actual data points will be plotted by plt.scatter. X and Y have defined, and C will define the class separation. That C represents the color here. For Y class 0 and 1, we have to choose different colors. That's why we have taken C equal to Y. And for logistic plot, we have to take X plot data points and Y predicted probabilities for X plot. And color has been taken as black, and label is logistic regression. And these are the X label, Y label, and title of the plot. Again, plt.show, legends, and grid. So you can see these are the actual data points, and these are the model fit. Hope you all are able to plot this graph. Please see this cell and try to plot this graph. Now we have to predict, we have taken a test task for this data. Here we have defined a classify function, which have taken X, W, and V. W and V already defined, already have got. These are the final weights and as final bias, and have to choose a threshold. We have chosen 0.5. That means if the probability is greater than 0.5, then the data point will be goes to the first class, the one. And if the probability is less than 0.5, then data will be goes to the zeroth class. So probability will be computed by the predict function, and it will return the probability greater than equal to threshold 1 if a probability is greater than equal to threshold as 0, and the probability. It will return two parameters. One is the 1 and 0, and second the probability. What is the probability? 0.6, 0.7 or other. So here is the task. We have taken a new variable the 2.2, if a student read 2.75 hours, then what will be the prediction of his pass the exam? So classify function will be written two parameters. So here are the two parameters, label and probability. Classify will take new hours as input and weights and bias. So now we have label. Label is 0 or 1 and probability is a continuous value. So these are the results printed here. The predicted probability of passing and the predicted outcome. If here we apply another condition, if label equal to 1, then pass, and else fail. It will print the outcome as pass and fail. So you can see in the results, predicted outcome is fail because the probability is less than 0.5. You can take different example of hours and try to get the different result. Now we will do the logistic regression of on a large data set which have several features. You all have got the herd dataset file on Canvas. Please download it and upload it in Google Colab from here. Upload the data file from here. Import the pandas library to read the data file. Now define the data set into a variable data and copy the path of data file here. Data.head will print the first items of data. Here we have 13 columns. That means we have 30 features, but one feature is target. This is the heart disease data set. The features will show a patient has heart disease or not. If he has heart disease, the target output will be 1. If he has not, then the target output will be 0. So in X, we locate all the columns. ILOC is the for location. All the columns between 0, all the rows by removing the column 13. It will not take the 13 column. All the rows between 0 to 13 column, but it will not take the upper bound column, the 13 number column. So it will take all 12 columns with the rows. The colon is representing all rows. And Y is taken on only the 13 column. Now to count the number of samples, we can try to compute the length of the X data set. So here we have 1025 samples. Here we have normalized the data set without using a standard scalar. X minus X mean divided by standard deviation of X. And now data set has normalized. So here we will do the logistic regression using the sklearn library. These all function has inbuilt in these libraries. We can import these functions and directly apply on our inputs. This will reduce our time and work. So first we have to split our data set into train and test set. and test size is 0.2 here. That means 20% data will goes on the test set and other data will goes on train test. Here is the separation will have shown. So to import the logistic regression function from sklearn library, type sklearn.linear model import logistic regression. So logistic regression is a class here which will define in the model, which will assign in the model variable, and maximum iteration will be taken as 1000. Model.fit will train the model on train data set, X train, Y train, and then to make predictions on to test the model. Now for here our model is trained and the optimal parameters have obtained. Now to make predictions, we have to apply the function which will already in the logistic regression class, because logistic regression class is in model. So model.predict is applied on X test, and accuracy is computed by mean of accuracy is what? Number of correct prediction upon total predictions. So number of correct prediction will be what? Whenever y predicted is equal to y test, which these are the correct predictions. We will take the mean of it. This will give us accuracy. So print accuracy, it is 0.81. Again, we will see how to compute a confusion matrix, because this is a binary class data. So we can get all the matrices and confusion matrix for this. So these all the matrices are also inbuilt in sklearn library. So from sklearn.matrix, we can import confusion matrix, accuracy score, and classification report. To print confusion matrix, we will import the C1 library, which will provide us a heat map and confusion matrix on the test data set, and accuracy just provide our predicted values and actual values on the accuracy score and confusion matrix function. Print confusion matrix is CM is our confusion matrix, so we have printed it. And classification to print classification report, provide our actual data and predicted data on classification report, and the accuracy will be print up to 2 decimal points. So here is SNS.heatmap. Heatmap will provide it called heatmap. Whenever the values are higher, it will provide a dark color, so we can see the difference. And whenever the values are lower, it will provide somewhat a light color. We have choose blues, that's why the color is blue here. FMT is equal to D will treat number as integers. If sometime it will represent any float numbers, it will convert it into integers. And A not equal to true will show numbers inside heat map. If you false it true, if you provide false in place of true, the heat map will not show the numbers. And these are the X tick labels, no disease, disease, and these are the Y tick labels, no disease, disease, and X label, Y label, and title of confusion matrix. Then show all these things. So confusion matrix is here and classification report is here. You can see the precision, recall, F1 score for all, and accuracy 0.81. Here we also got 0.81. And this is the heat map for confusion matrix. Our confusion matrix will be good whenever these diagonals have higher values. So that's how we can predict our model using logistic regression using sklearn library. You can see the cell and try to compute it in your own systems. If you have any doubt in this logistic regression, hands-on, please ask me. After this, we will continue with the neural network code. So now we will start with neural network code. First, we will do the scratch implementation using simple gradient descent method. Then we will learn how to use libraries for the neural network optimization. First, import the important libraries. Then again, define the sigmoid function and the derivative of sigmoid function. We will use this to compute the gradient. And the ReLU is another activation function and the derivative of ReLU function. The S type in this ReLU derivative dot S type float will convert all the number greater than 0 as 1 because the ReLU derivative is 1 for x greater than 0 and 0 for all. So it will provide us the derivative of ReLU derivative. And again, we will define the binary cross entropy here, which will y true and y predicted, log of y predicted. We have defined epsilon here because in computation, sometimes we have got undefined values due to log 0. So in computation, we have to take a small quantity written 0, which is e to the power minus 15 here, to remove these undefined values. And 1 minus y, this is the formula of binary cross entropy. You all have know. And the binary cross entropy derivative. And here also, to avoid undefined function in computation, we have taken the plus epsilon in denominator. So again, the HERT dataset file will be used. Import all the necessary libraries. This is the HERT datasheet. Okay. Now we have to split it in output and input function. So x will be input. So we will draw the target column as a column. Dot values will be extract the values from the target column. And while we will take the target column and dot reshape -1 will create a row vector for this. Like it is a column vector, so it will provide a array for us. It will reshape it. It is a column vector. -1 will provide us a numpy array as a column vector. To do mathematical operations from scratch, we have to convert it into a numpy array. So we have converted into a numpy array. You can see the y vector here. And again, to pre-process the data, in earlier code, we have normalized the data by scratch x minus x bar upon standard deviation. But in this code, we have taken the standard scalar function, and this function will transform data into the normalized data. Now again, train test split for the data set. X is the train data and X test is the test data. Y is the train data, Y test the test output. Again, same thing, 20% will go through the test data set. So input dimension is x dot shape 1. It will calculate the number of rows in X. Sorry, number of columns. X dot shape 1 will conclude the number of columns. So input dimension will be the number of columns here. Hidden, we have taken just try to remember the neural network architecture. We have one hidden layer, we have one input layer, we have one output layer. So in input layer, this input dimension will be the number of neurons in the input layer, and hidden dimension will have 16 neurons, and this is binary data set, so output dimension will be 2. Only 2 neurons here, and this is the learning rate defined and epochs. So we have initialized the weight matrices and bias for this. W1 V1 will be for between the input layer and hidden layer, and W2 V2 will be the for hidden layer and output layer. So np.random will initialize randomly the weight and biases, and V1 and V2 will be create a zeroth array. So for epoch we have taken as 100. So first we have to multiply the weight matrix and input data. So Z1 will add it by bias. So Z1 will provide this. This is the forward pass. And then again we have to take the activation function on this thing. If you remember that. So we apply the ReLU activation for the hidden layer. Z1 is the output for the hidden layer. A1 is output after the hidden layer. And then again for the output layer Z2, which is dot product of A1 and W2 plus B2 is bias. And again, we have applied sigmoid function. We have taken only one neuron. Sorry, two neuron here. So sigmoid function will provide the probability for the input Z2. So here a empty list has been created for loss and accuracy. And binary cross entropy, the definition already is given earlier. Binary cross entropy will be calculated for Y and the output of the neural network A2. Then we have the loss of binary cross entropy. Now we have to minimize it using gradient descent. So we will compute the gradient. These all are the mathematical computation. We have to apply the chain rule. So first, the binary cross entropy derivative will be computed. Then we have sigmoid function. So the sigmoid derivative will be computed, and this operator will also compute the dot product of A1 transpose and dz2. So dw2 will give us the derivative gradient of loss function with respect to w2, and dv2 will provide us the derivative of loss function with respect to b2 bias. So again, though the b has a plus here, so the derivative will again and again compute for each sample. So we have to use sum, and x is equal to 0 will keep it as a row vector. So the computation of matrices will not make a trouble. And again, for input layer, the gradients will computed dz1 multiplied by w2 transpose and ReLU derivative, because in hidden layer we have used the ReLU derivative of z1. Then for dw1, this is the derivative of loss function with respect to w1. Again, this is the bias derivative, and this is the gradient descent. LR we have defined earlier, 0.1, W1 equal to W1 minus. Okay. So loss tree is an empty list. So the first sample we have got the loss. First epoch we have got the loss. So it will append in the loss tree list. And to calculate predictions, if A2 greater than 0.5, a step integer will return this as 0 or 1. So it will define as if it is greater than 0.5, it will return 1, and if it less than 0.5, it will return 0 to us. And accuracy, again, the correct predictions mean is accuracy, and accuracy will be added to the accuracy list, history list. Now, if epoch, we will print only 10 epochs up to, because epochs are 100. So if epoch divided by 100 is remainder equal to 0, this will print. Predictions again takes, if A2 greater than 0.5 dot step integer will return 1 for greater than 0.5, and accuracy, and this will print the loss and accuracy for every epoch after 10 epochs. So you can see the loss is decreasing here and accuracy is increasing here. So I hope you all have understood the how to do this scratch things with neural networks. Now for the test set, we again computed So for beginners, you can use a book which is available, Python Machine Learning for Beginners. And I will provide the book links on Canvas. But we do not have to do these scratch links now, thankfully, to the libraries. We will learn how to use libraries. This will short the code very easily. So do not worry. This is to all for understanding how neural network will work. So again, the test for the tested, the forward pass will begin. X test W1 will be dot product and V1 is add here. So the for the Y prediction of test set, the sigmoid function will be calculated and compute accuracy function is defined here. You can define compute accuracy here also. So we have computed it accuracy directly from this function and the test accuracy have computed it at 0.88. Our train accuracy have reached up to 96 and test accuracy is 0.88. So if you are not able to understand anything, you can ask me and we will begin the neural network implementation using inbuilt functional libraries after this. We will see how all optimizers can minimize the neural network loss. So you have gotten the mobile price dataset on Canvas. You can upload it from here. So the all important libraries, I think all are familiar to you. TensorFlow is the libraries which will provide us the model optimizers and the other thing, categorical and sequential things we can do using TensorFlow also. I do not define any function. TensorFlow is basically the library for machine learning tasks, neural network tasks. And here is the mobile price dataset. So price range have provided 4 categories, 1, 2, and others. So this dataset has 4 classes. So we have imported the 2 categorical thing from TensorFlow library. We have used it here. And first drop the price range column and then price range dot extract the values of price range and convert it into categorical values. Convert target values into a format suitable for multi-class classification. This format will be understood by the model for classification. So you can understood by this, if one is for first entry after the computation, then the sample will be belong to the first class. And one is for the second entry, then the model will belong for the second class. Same for the third, same for the fourth. So for now, standardize the dataset using scalar.fit. Again, train test split on the dataset. You all are able to see the mobile price dataset on your screen. I mean, on your own cell or not. So first we have to build a model. This is the neural network model. Sequential we have imported, so it will remain in a sequential order from the TensorFlow Keras models. And first in model, this is the definition we have created build model, and model dot add function will be already in the library. So model dot add dense, we have already imported dense from here. So dense will create a layer of 64 neurons, 64 neuron, which will be a dense layer, and activation ReLU will be applied on first hidden layer, and input shape will be x dot shape 1. That means the column numbers of x data. So again add second layer, which has 32 dense neurons and activation ReLU. Again add third layer, which is again ReLU functions and 16 neurons. So we have 4 classes. So we have to, sorry, is I am not audible? Am I audible to all?
Yes, you are audible.
Okay then. So this we have to take 4 neurons only, and we have to take the softmax function, which will provide probabilities for these 4 classes, and what which neuron will provide the highest probability among these 4 will the sample will belong to that class. So that's how the model works. So now we will see how can we use the inbuilt functions of optimizers to optimize the loss of the neural network. So just directly define the model by build model definition. It will provide the model to the model variable, and then take optimizer is SGD. SGD has already, you can see here, imported here from TensorFlow.keras optimizers. That's why only SGD will define the whole definition of stochastic gradient descent, and learning rate is a hyperparameter which will be taken at 0.001. And model.compile sets up the training architecture and mechanism. So we have to first compile the model and tell the model what to use. We have to use optimizer as optimizer. So you can provide any variable here and put optimizer equal to that. And the loss will be used as categorical cross entropy because we have multi-class classification, and the matrix will be used as accuracy. So you can see here, we have taken the 10 epochs only here. You can take more epochs. It will take time. So you can do practice with this. And the train data set model.fit function will train the model. And in history, the all training data will be saved. And batch size, because the stochastic gradient descent, so it will be 16. And verbose 1 will show these things to you. If you take verbose 0, these things will not shown up. So the accuracy is increasing and the loss is decreasing here. You can take more epochs and try to run this code. The accuracy will increase. by the time. And then try to plot these loss and accuracy versus epoch. So I already mentioned the subplot command in the basic hands-on. So we have to plot two subplots. First is for training loss and second is for training accuracy. These all are the basic commands of label, title, and these things. So you can see how, according to the epochs, the loss is decreasing and the accuracy is increasing. This visualization is a necessary thing to see how our model is trained. Now we have done the training thing and now we have to test our model. So just import the classification report, confusion matrix, and ROC curve and AUC from sklearn matrix. And predicted probabilities of X dataset will be assigned in this variable. By model.predict will be test our model on unseen test dataset. And by predicted labels, this will define labels by these probability. These variable have only probabilities, but np.arguments will return highest probability to us, and the highest probability will goes to that class. Means in this we have four neurons in the output. In this four neurons, which neuron have highest probability? We will define one for that class as this matrix we can see, so that we can compare the accuracy. So this will return the test labels for the test data set. So first, this will compare the prediction labels, and this will compare the prediction label with the test data set. And then we have our classification report by test labels and by prediction labels. So the test label is the actual labels and the prediction labels are the predicted labels by the neural networks. And digits equal to 4 will provide 4 digits up to. And classification report has shown here. Again, the confusion matrix. So now you can see how the code is reduced by using these libraries. The whole computation has been done behind the scenes. So confusion matrix, because we have 4 classes, so the confusion matrix will be 4 by 4. And again, ANR true will provide the values in, and D will take integers. So here we have taken an empty list of false positive rate, true positive rate, and ROC, AUC. So we have 4 classes. So false positive rate and true positive rate will be computed for all these 4 classes. And ROC curve have already imported by the library here from sklearn.matrix. So This will compute the ROC curve from against the test labels and the probabilities. I will provide the for the first class, it will compute, and again for the second class, it will compute. And AUC is also imported by sklearn.matrix. So for ROC of ith class, the AUC will be computed by providing the FPR and TPR, which is false positive rate and true positive rate. So here we have plotted these things of ROC and AUC, ROC curves. So we have to plot these false positive rate, we have to take it as an x-axis, and TPR, we have to take it as on y-axis, and class first AUC will be this, and again for class second AUC will be ROC, AUCI will be computed from here, and again the plot has been shown. You can reduce the plot size. We because ROC, FPR and TPR between 0, 1 and 0 to 1. That's why we have taken these things. And for dash line, we have provided this command, which is the guess line for predictions. And you can see for class 0, the AEC score is this. For class 1, the AEC score is this. And class 2, 3. So this is how we can plot the ROC metric. Again, we have to compute, we have to train our model for SGD with momentum. Again, import SGD from this library, and model will have to be again defined, because if we don't define the model, it will take the trained model and we can't see how the other optimizer will do work on the model, because it will take the optimal parameters of previous model. So we have to define again the model here. It will take the raw model again the randomly initialized parameters. So optimizer here defined SGD. So for SGD with momentum, we have to define the additional parameter of momentum. Here we have taken 0.9. And in all optimizers, we have taken the constant learning rate 0.001 to see how this the all optimizer will compare with this constant learning rate. And now compile the model. Now our model is ready to train. So we have defined history previously. So we have taken a new variable history1. Model.fit will train the model for 10 epochs. This is SGD with momentum. So the accuracy is increasing by the time and loss is decreasing. So to plot these things, again, now we have to take in loss metric from history. History has all the metrics, loss and accuracy. So history1 dot history loss will take the loss for each epoch from this data. History1 is a list here. So provide the label for this, and again take out the accuracy from history1 and SGD with momentum accuracy. You can visualize the loss decreasing and accuracy increasing by these graphs. Again, to test the model, we have to use different metrics: classification report, confusion matrix, and ROC and AUC. So again, predict the probabilities for the X test, then compute the labels for the predicted probabilities, then short the test labels for actual labels. We have taken the 16 batch size, that's why the 16 is showing here. So in one batch, the 16 samples will be taken. So again, the classification report will be printed using the same command. And you can see now accuracy have increased. Hello? Hello?
Yes, you are audible.
So for to compute the confusion matrix, again provide this command confusion matrix by test labels and by predicted labels. Provide the heat map command, and you can see now the diagonal have higher values. So the model is predicting good. Again, for the false positive rate and true positive rate, we have to create empty list, and this list will be taken by for first class false positive rate and for second class for first class true positive rate. So these all are the same things. Just optimizer has been changed. So you have to just change the optimizer again and again to do the comparison between optimizers. So FPR, TPR will be computed for each class and plot it here. The AEC score and ROC curves have shown here. For class 0 is AEC is higher. That means for class 0, the model is predicting best. Again, we have to employ the ADA grade optimizer on our model. So import it and again redefine the model here and define the optimizer ADA grade learning rate equal to 0.001 and compile the model, provide the loss and provide the accuracy. You can change the metrics here. You can provide the loss also according to your requirement. So here we have trained the model for 10 epochs. Again, the plot has been shown for the train accuracy and training loss. Again, predict our model, test the model on test data set. And the classification report will show the test accuracy, which is this. Again, the confusion matrix for the test labels and predicted labels and actual labels. Again, we have to compute the false positive and true positive rates. Now for the RMS prop. The model will be redefined. And again, click learning rate 0.001 and compile the model with categorical cross entropy and accuracy metric. You can see the loss is decreasing and the accuracy is increasing here by training the model. Again, we have changed this variable as history 3. Extract the loss from this list and show the training loss and training accuracy with epochs. Then predict the model on the test data set. And classification rate will be show the accuracy, F1 score, precision recall for all classes. 0, 1, 2, 3 are the classes. And then confusion metric. Again, ROC and AUC score for the RMS prop. And then now ADAM optimizer. Import the ADAM optimizer from this library and redefine the model and take it learning rate at 0.001. The accuracy and loss, the model will be trained for model.fit and all data will be assigned in history 4. And here is the visualization of training loss decreasing and training accuracy increasing. So now again classification report and confusion matrix. Predict the model, get the test accuracy from this command and plot the confusion matrix. And again ROC and AUC curve. So to compare in one graph these all optimizers, we have taken the variables to plot line plot of these all loss and accuracy by epochs, SGD loss. First take the loss from history list, which is SGD loss. Then take the loss from history 1 list, which is SGD with momentum loss. And then take the loss from history 2 list, which is EDA grade loss. And again, take the accuracy. Now you can see here the comparison in one graph only. So you can see the ADAM optimizer have working good here in terms of loss and accuracy. So this is all the things to do with neural networks using different optimizers. If you have any doubt, you can ask. For the next 10 to 15 minutes, you can try these codes on your own and let me know if you have any trouble to upload the file and to at least try the basic things like this to upload the file and to see the data set and to split the data set. I will show the particular cell you want to try. Also, one thing, if you want to upload our code files in your own Google Colab, just click on this file and upload the notebook. Then you can try to run these files.
So participants, you can see if you have got all the data files, all the code files, and try to run it. So you can practice for next 10 to 15 minutes. We are all here for any of your questions or any doubts. Meanwhile, we can also suggest books. So books links will be shared on Canvas.